The Zener diode is an unusual diode, especially when compared to a standard p-n junction diode. First of all, in its operation, it is always operated in reverse bias. So we will try to pass a current through the diode in reverse bias. And it will work because the scientists have made the Zener diode able to do so. So when there is a current flowing through the Zener diode, the voltage across the diode will stay stable at its rated value. Let me just emphasize that a little bit more. The values of these are available from the preferred range. So you may have, for example, a 3.3 volt Zener diode. So as long as we can maintain a current going through the diode, this will measure 3.3 volts. We could get another value from the preferred range. It could be that we get, let's say, 4.7 volts. And that means as long as we can maintain a current going through there, we will measure 4.7 volts across the diode. It does vary a little, but it will basically produce its rated voltage. We'll measure across the diode its rated voltage. So, on to part 2 of the story. I just need to remind you what happens in parallel circuits. If, for example, I connect a supply here, which is, I'll pick a simple number, 10 volts, then that means across this resistor there is 10 volts. This resistor is in parallel. There will be 10 volts across that. If I connect something else in parallel with it, whatever that component is, there is 10 volts across that as well. So remember the rules of parallel circuits. And that brings us to the operation of the Zener in a very, very crude and simple circuit. I must stress, in the real world, they get a bit more technical than this, but this will give you an idea of how we could possibly use a Zener. So here I have a supply, so a simple DC supply. There is a resistor, and here is our Zener diode. If we make this supply, I'll stick with this number that we had a few moments ago. Suppose we make it 10 volts. And let's say our Zener diode is rated at 5.1 volts. So it's a 5.1 volt rated Zener. With 10 volts here, a current will go through the circuit. So current will flow. And if you remember what I said earlier, as long as current is flowing through the Zener, the voltage across it, that is here, will remain steady at its rated voltage. So we have a 10 volt supply, but I'm taking out here a 5 volt supply. I know it's 5.1, and the balance of our supply will be measurable across this resistor. So just Kirchhoff's laws, that voltage in series with that voltage, this is going to be 4.9 volts. Okay, so that and that add up to 10. And I could connect whatever I want to have a 5 volt supply over here, whatever this is. Let me give you a simple scenario. It could be that you want to produce an extremely crude and simple mobile phone charger producing 5 volts for your mobile phone, and it's going to work on your car. So in such a situation, your car output is going to be 12 volts, and we need 5.1 volts for your charger. This is for your phone charger. And that means that we're going to get 5.1 volts there, and this is going to go up to 6.9 volts. So hopefully you get the idea. This is an extremely crude and extremely simplified regulating circuit. It just gives us a steady 5 volts across this point. It won't be able to deliver a great deal of current, and there are much more appropriate and more sophisticated circuits around. This just gives you an idea of what you can do with a Zener diode. Remember, it's always connected in reverse.